or have questions about?
Number 2.
And then we can do 3 or 4. So everyone choose one of those, and then majority will do that. I see majority choose. So we'll do 2 and 3. I gotta find them because my numbers are weird. Alright, so for number 2, it's saying the following graph contains line L, which is this one, and point M, which is labeled, and line L contains these 2 points, and then it tells you the order for M. So for part A, we have to state the perpendicular slope of line L, so we have to figure out what the slope is. You could do that by counting, but the graph is, the scale is counting by 2, so that might be a little hard. So I'm just going to use the slope formula. Between these 2 points to get that slope. So this would be negative 4 over 10, or negative 2/5. So I know that's going to be the slope of that line. Then to find the perpendicular slope, I'm going to take that slope and flip it and make it positive. So that perpendicular slope would be a positive 5 over 2. Then part B is a little bit more challenging because we have to plot another point that has whole numbers in the order pair that would lie on a line that's parallel to the given line, but that would go through M. So if it's parallel, it's going to have the same slope. So I'm going to plot a bunch of points. You just need one of these, and I'm going to write which ones they are. But remember that if it's in the middle of anything, that's an odd number. If it's on a line, that's an even number. So if I was using this slope, I could go up 2 and to the left 5. So negative 9, negative 1 could be one of your points. Or negative 14, 1. Or I'll go the other way. 1, negative 5. Sorry. Yeah, that was right. 6, negative 7. And then there's 1. 11, negative 9. So any of those points you could have plotted, you don't need them all, really just one. If you want them all, that's fine. Questions about that? So on number 3, we have to figure out which set of equations are parallel, which ones are perpendicular, which ones are neither. So we're going to start with the ones that are already solved. The 7/9 and the 9/7. They're not the same, so they're not parallel, and they are reciprocal, but one isn't negative. So those are neither. I'm just going to write B. Then if I look at A, one of these equations need to be solved. Get rid of 2x by subtracting. So we have y equals negative 2x plus 5. And if I look at those 2 slopes, they are reciprocals and one is negative, so those would be perpendicular, which by default would mean C are the parallel ones, so I'm going to solve those, just so you see that. So subtract 3x on both sides, subtract 12x on both sides. And then if we divided everything by 5 and by 20, the top one would give us y equals negative 3/5 x plus 9/5, and the bottom would be y equals negative 3/5 x plus 9/5. So we can see that the slopes are the same, so those are indeed parallel. You also, if you were using Desmos, could have put these two in to see, do they intersect, do they not intersect, do they intersect to make a 90-degree angle, and count the slopes. Questions on that? Okay, let's talk delta math. But we're going to be talking about function notation, which you probably haven't seen before, but you may have done a bit of this. So when we do function notation, we'll talk about what exactly that means. But really, we're just evaluating. Has anyone heard that word before? What does it mean to evaluate? Kind of. Anyone else have any thoughts? Okay, in not a math sense, sure, to look at. Okay, we'll talk about that. So previously we've been dealing with a lot of equations where we have some y equals 2x minus 8, but now we're going to see them as function notation where we have the same 2x minus 8, but instead of y, it's f of x equals 2x minus 8. The y and the f of x are really the same thing, but with y we're really dealing with equations, f of x we're really dealing with functions, but they're really the same thing. But you could think of f of x as like a replacement for y. So when we read it, we're reading it as f of x. And they may change the letters, and you may see g of x, h of x, j of x, k of x. That part doesn't matter. It's still y, no matter what. So when we evaluate in function notation, we're going to right now be looking for a specific value. We'll be given a specific value that we substitute or put in place of x. So we're going to do this with the first example. So in this one, we're given some equation, and these are not, it's not multiple choice, these are all part of this answer. So we're going to put that number in anytime we see an x. So that would be f of 5 equals 5 plus 7. And then we just figure out what is 5 plus 7, which is 12. So then we would write that as f of 5 equals 12, or you can write it as f of x equals 12. So the first one means when x is 5, y is 12. The second one just means y is 12. Questions on that before we continue? Okay, we're going to do part B. Same setup. F of negative 1 equals negative 1 plus 7. What is f of negative 1? And then let's do part C. F of negative 3 equals negative 3 plus 7. What is f of negative 3? So we're just putting in some value for x and figuring out what is our y value. That's all we're doing. Good. Questions about that? We're going to do one with fractions and one with the square, just so you see what that looks like, and then I'll show you how to do one in the calculator / Desmos. So for 3, we're doing the same thing. I'm not going to rewrite this first part because we already have it. I'm just going to say this is 2/3 times negative 3 minus 1. So I would need to multiply the 2/3 and the negative 3 first, which would be what? Negative 2. And then h of negative 3 is what? What is that final answer? Negative 3. H of negative 3 equals negative 3. Questions on that before we do part B and C? Okay, so same process, but now we're using different numbers. So h of 0, put in 0 where x was. 2/3 times 0 would give me what? 0. So h of 0 is what? Negative 1. And then for the last one, h of 9. 2/3 times 9 is what? This would be 18 over 3. And h of 9 is what? Okay. So the biggest part of this is when you put it in, make sure you are doing math correctly. That way you get the correct answer at the end. Okay, we're going to do number 4. Now we have 2 x's. It's going to be very similar, but now we're just putting it in twice. Because we have negative numbers and exponents, keep that in parentheses with the exponent outside of the parentheses. Square the number first. What would that be? It would be positive 16. I'll show why here in a second. So then f of negative 4 equals 20. Yes. So in your calculator or in general, if you are using the parentheses and then squaring, you'll get a positive number. But if you're not using parentheses and you're squaring, you'll get a negative. Because this is really saying negative 1 times 4 squared, so don't do this. But also a negative times a negative would be a positive in general. Okay, so f of negative 1, let's do that one. Negative 1 squared would give us 1. So f of negative 1 is 2. Any questions so far before we do this last one?
Why is the negative 4 on the first one go to positive? Do you know this?
Because a negative times a negative is a positive. And then the positive 7, you don't really need the parentheses, so I'm just going to do that anyway. So 7 squared is 49. And f of 7 is 42. Questions there? Okay. Did you have a question? Okay. So we're going to put number 6 in the calculator, just so you see how you could quickly double check yourself. You're going to go into your y equals at the top, and you're going to type in that equation for number 6. So negative x, the button next to alpha, squared, plus 6x minus 4. So y equals, type that in. X is right here, next to alpha. Then you're going to go into the table. It's in blue above graph, so second graph. And this is a really quick way to look for any y value given any x x value. So in the problem, it says f of negative 3. So I could go up, find when x is negative 3, the y value would be negative 31. For b, f of negative 1, the y value is negative 11. And then for c, f of 5, the y value is 1. So that's a quick way to look and see, did you get those numbers right or not? Yes. Questions about that? Now, while you can't use Desmos on the test, while you're practicing on the Delta Math, you could, so let's say I put that in. Minus 6x plus 6x, I don't know. If you go into the gear wheel and make this a table, there'll be only 5 numbers up there, but you can put in others. So let's say I want to know what f of 5 is, I could put that in and it would tell me what that is. You can do that and you can keep going. Okay, questions there? Move on to the back. We're going to go to number 11. So let's read through this. Anthropologists use the length of certain bones of a human skeleton to estimate the height of a living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x, the function h of x equals 61.41 plus 2.22x can be used. We're going to find h of 46. So the exact same thing that we were just doing, we're going to put 46 in for x. And figure out what that is. So go ahead and do that in your calculator. Tell me what number you get. What number did we get there? 168 point what? 1. Was that it, or were there other numbers? Okay, so the first part is asking to find it, to find the number. Then the second part is asking, what does that mean? So we'll start with the 168.13. What does that mean? Say that again. Not the femur, but the... Yes. So this is the height of the female in centimeters. So then what does the 46 mean? The length of the femur. Maybe in centimeters, I'm not entirely sure about that one, possibly. Okay, so being able to describe that in context will also be part of that function notation. Questions about that before we move on to the graph? Okay. In the graph, you're doing the same thing, but now you're looking at the graph, you're reading it. So if I say, what is f of negative 4, I'm looking at when x is negative 4, what is your y value? Where does this cross the y value? I'm going to outline your x and y axes. So if I'm looking at when x is negative 4, what is your y value on that function? Close. So when x is negative 4, your y value is 2. What about f of 0? What is your y value? 0. F of 2. Not negative 1, but negative 2. And then f of 5. That one's second. Do we have any questions on how we just got those? Go on to the next page. Great. Now this part is very similar to what we started with, except it's given domain with a set number of values, where we have to find their range value. So we're going to do the same thing that we did before, put each of these in, and then we're going to find each answer, and then we're going to write our answer in the solution set. So let's start with 4. F of 4 equals 4 minus 5. What is f of 4? Negative 1. Negative 1. And then f of 6 would be 6 minus 5. What is f of 6? 1. And then f of 8 would be 8 minus 5. So what is f of 8? 3. So then because our domain was given to us in the solution set, we have to write our range in the same thing. So the range, least to greatest, in curly brackets, -1, 1, 3. So as you're doing this, I should not just see answers. I should see that you put this into the equation, did the work, found the answer, and then in this case put it in solution set. This, yeah, because you put this in and then you just did that math. But like the fraction one, show me what you got there, and then keep going. Questions on this? Are there any others on this page we want to see do go over before we move on? If not, go on to the next page. What's different about these than what we were just doing? This is the answer instead of us having f of some number. Now we have f of x equals this. That means we're given which variable right now? The y. So these are all our y values, and now we're going to go back and find x. So the biggest thing of all of this is knowing what you're solving for and solving for the right thing. So because we're given y, we're going to take this number, get rid of the f of x since that is y, and rewrite the equation with that in its place. And then we're going to solve for x. How would I do that? If I'm not adding 7, I would subtract. So that x equals -12. So you might see that as x equals -12, or you might see it as f of -12. Either or. questions on that before we do B and C? Okay. The process here will then be the same. I know I'm going to be subtracting 7 for each of these, but I am going to replace the y value first. So that if I replace the 0 and I subtract 7, the x value for when y is 0 would be what? -7. And then when y is 10, if I subtract 7, what is my x value there? Questions on that? Looking at numbers 2 through 6, are there any of those we want to see go over before we go to the next part? If not, go on. So the graph is the same, but now we have y values. We're looking for x values. I'll outline our x and y axes again. But now I'm looking at when y is -2, what is your x value? I'm looking at when y is -2, that would be along this line. Not 1, but 2. Okay. For f of x equals 0, what is your x value there? 0. When y is 2, what is your x value? This one has 2 answers. Give me one of them. So -1.5 would be like right here. Go back the other way. -0.5. 0.5 might be a little off, but 0.8 might work. Because it's like super close to -1, but not quite. And what's the other one? Where else does that cross -4? Okay, and then f of x equals 4. What is your x value there? -2. Do you have any questions on how we read these graphs? So we're going to do one of these, more if you guys want. Same kind of thing that we did before. Now we have the range. We're going to go back and find the domain by putting each of these numbers in, replacing f of x, and solving. So this would be -3 equals x minus 5, where we would do what to solve this? Add 5. So that x equals +2. And now that we know that process is going to be the same for the other two, I would still add 5. And when y is 0, what is x?
0.
So y is 0, but what is x? And then for the last one, when y is 5, what is x? So then we would list our domain values least to greatest. 2, 5, 10 in kilogram. Questions about that? Are there any others on this page you want to see do go over? Okay. So I'm going to give you a few different options of what you can be working on for practice. If you want to keep working in these notes, you can do that. You guys have 2 delta maths that are due on Friday, the parallel and perpendicular lines, which many of you have started, and the linear I'm looking at the wrong thing, and the function notation for what we just did today, so you can be working on those. There is a review up here for the quiz that is next class. If you want to grab that and start working on that, you can do that. If you need to finish your tests, you can work on that. If you want to do retake work, finish one of the delta maths first. Yes.
The delta maths in the silence or
These 2 delta maths are in the silent.